Start already? So we are going to talk about wave. Okay, so what is wave? When a thing is swinging or vibrating motion to a fixed center point along the line, that is what you call wave. For example, swing. Okay, you see that you have a fixed point here. So when you have a fixed point here, and then the swing or the pendulum bob swinging to and fro to the fixed point, that it actually produce wave. Okay, so the keyword here that you must have is the vibration motion. You must have vibration motion that it, and then you have a fixed point, then it repeat the same pattern of movement. That is what you call wave. So in your syllabus you have a few type of wave. One, you call it progressive wave. Progressive wave means that you see that the wave is actually like moving. Okay, I actually show the video in our Zoom class. That is what you call progressive wave, means that you see that it is in moving condition. Static means that it look like static. Okay, that you have a fixed beginning point and ending point. Okay, for example, guitar string. Okay, once you strike the string, you can have a vibration like this, right? We go up and down. So this is static wave. Or another word, we call it stationary wave. Of course, you can also produce a wave like this. Okay, that you still have two fixed point, that it produce a wave. We go up and down. That is also a stationary wave. Or you can actually produce more like that. Okay, more like that, and then you still have a fixing point here. Then this is stationary or static wave. Progressive wave is a wave that is moving along. You can see the propagation of wave that moving. Okay, so you have this is first category, two type. Another category that you have to learn here is what is mechanical wave. Mechanical wave is a wave that you can see like guitar string, drum, sound wave. That is mechanical wave. Another wave is what you call EM wave, electromagnetic wave. Look at the word electric. Magnetic means that you have electric and then you have magnetic, you combine it, it is EM wave. We actually learned this in Form 3, Chapter 8, that we learn about radiation, right? Radiation, we learn ionizing radiation, non-ionizing radiation. That radiation wave like X-ray, gamma ray, and also X-ray, gamma ray, or we have the full list, right? Radio waves, ultraviolet, sorry class. Okay, ultraviolet, X-ray, and gamma ray, these three are ionizing wave, which actually the whole series of wave that we learn in Form 3 here is actually EM wave, means that they are made up of electric field and magnetic field, which is 90 degrees to each other. Okay, so another category of type of wave that we learn in this chapter is transverse wave and longitudinal wave. Okay, longitudinal wave. Okay, so transverse wave is where the wave or the particles vibrate perpendicularly to the propagation of wave. Okay, for example, I have a thread or tali. Okay, I swing it up and down. Okay, you can imagine that I fix it at the wall and then I swing it up and down. You see that the particles actually moving up and down, but the wave travel like this. So it is 90 degrees. So this is what you call transverse wave. Longitudinal wave, let's say I have a spring like this. And then I push the spring and then pull it back. Push the spring and then pull it back. So you can see there is a compression, rarefaction, compression, rarefaction like this, right? So you see that the movement of particles is left and right. And then the propagation of wave also like this, so it is parallel. So when you talk about longitudinal, you look at the word L, it is parallel. The particles vibrate parallel to the propagation of wave. So you look at the word T 90 degree. Okay, the particles vibrate perpendicular to the propagation of wave. So you have three category of wave in your syllabus that you have to really know what is that and what is the example of each type of wave. Okay, progressive wave, stationary wave, mechanical wave, EM wave, transverse wave, and longitudinal wave. Okay, thank you.